Picture this. Right now, as you listen to these words, billions of electrons in your brain might be doing something extraordinary. They could be existing in multiple states simultaneously, dancing between possibilities until the very moment your consciousness observes them. At that instant, they collapse into a single, definite reality. If this sounds like science fiction, you're not alone in thinking so. But what if consciousness itself is the secret ingredient that transforms quantum possibilities into the solid world we experience? What if your awareness is literally creating reality, one observation at a time? Welcome back to another journey into the profound mysteries that connect the deepest layers of physics with the most intimate aspects of human experience. I'm here to guide you through one of the most controversial and mind-bending questions in modern science. Does consciousness actually collapse the quantum wave function? And perhaps even more fundamentally, does the wave function truly exist at all? Or is it merely a mathematical convenience we use to describe something far stranger? Tonight, we'll drift through the quantum realm where particles refuse to behave like the solid objects we know, where the act of observation seems to create reality itself, and where the boundary between mind and matter becomes surprisingly blurry. We'll explore theories that suggest your consciousness might be operating according to quantum principles, processing information in ways that classical computers could never match. This isn't just academic speculation. If consciousness really does play a fundamental role in quantum mechanics, it would revolutionize everything we think we know about the nature of reality, free will, and what it means to be aware. We'll examine the evidence, the controversies, and the profound implications of a universe where mind and matter dance together at the deepest level. But I want to be clear from the start. Much of what we'll discuss remains highly speculative. The scientific community is deeply divided on these questions, and will explore both the tantalizing possibilities and the serious objections that keep many physicists skeptical. This journey is about expanding our sense of wonder and possibility, not making definitive claims about the nature of consciousness or reality. So settle in comfortably, let your mind relax into curiosity, and prepare to question some of your most basic assumptions about the world. Whether you're a long-time explorer of consciousness or someone who's never considered the quantum nature of reality, this exploration will offer you new ways to think about the most fundamental questions of existence. To understand how consciousness might be connected to quantum mechanics, we need to begin with the mystery that has puzzled physicists for nearly a century: the measurement problem. It's a puzzle so strange that even the scientists who work with it every day struggle to explain what's really happening. Imagine you have a coin that's spinning through the air. In our everyday world, that coin is either heads or tails at any given moment, even if we can't see which side is showing while it spins. But in the quantum world, particles behave very differently. A quantum particle can genuinely exist in what physicists call a superposition, simultaneously in multiple states at once until something forces it to choose a definite state. This isn't just a limitation of our knowledge or measurement tools. According to quantum mechanics, the particle literally doesn't have a definite position, spin, or energy until it's observed. It exists as a mathematical entity called a wave function, which describes all the possible states the particle could be in and the probability of finding it in each state. The wave function is one of the most successful mathematical tools in all of science. It allows physicists to predict the behavior of quantum systems with extraordinary precision. Yet despite its predictive power, nobody really knows what the wave function represents. Is it a real physical thing that exists in the world? Or is it simply a mathematical description of our knowledge about a quantum system? This question becomes even more mysterious when we consider what happens during measurement. When a scientist sets up an experiment to detect a quantum particle, something dramatic occurs. The wave function, which had been describing multiple possibilities simultaneously, suddenly collapses into a single, definite outcome. The particle that was everywhere becomes a particle that is somewhere specific. But here's the puzzle that keeps physicists awake at night. The equations of quantum mechanics don't actually describe this collapse. The Schrödinger equation, which governs how quantum systems evolve over time, shows wave functions spreading out and becoming more complex, never collapsing. Yet collapse clearly happens every time we make a measurement. So what causes it? As you contemplate this mystery, notice how it might reflect something familiar in your own experience. Have you ever been in a situation where multiple possibilities seem to exist simultaneously in your mind until you are forced to make a decision? That moment of choice when potential becomes actual mirrors something profound about the quantum world. The measurement problem has spawned numerous interpretations of quantum mechanics, each attempting to explain when, how, and why wave function collapse occurs. Some physicists argue that collapse is a real, physical process. Others contend that it's merely an illusion created by our limited perspective. Still others propose that collapse never actually happens at all, and that all possible outcomes continue to exist in parallel universes. But there's one interpretation that stands out for its boldness and its implications for consciousness. The idea that conscious observation itself causes wave function collapse. This interpretation suggests that the boundary between the quantum and classical worlds isn't determined by the size of objects or the complexity of measuring instruments, but by the presence of conscious awareness. The roots of this idea trace back to some of the founding fathers of quantum mechanics. John von Neumann, a brilliant mathematician who helped formalize quantum theory, proposed that measurement requires a chain of interactions, from the quantum system to the measuring device to the recording apparatus to the conscious observer. But somewhere in this chain, he argued, the wave function must collapse. Where exactly does this happen? Von Neumann's analysis suggested that the collapse couldn't occur at any purely physical stage in the measurement process, because physical systems should themselves be governed by quantum mechanics. The only place where the buck could stop, he proposed, was at the level of consciousness itself. The conscious observer, existing somehow outside the physical world, described by quantum mechanics, would be responsible for collapsing the wave function and creating definite reality from quantum possibilities. This idea was further developed by Eugene Wigner, a Nobel Prize-winning physicist who took the consciousness interpretation seriously. Wigner argued that consciousness must be fundamentally different from physical matter because it has the unique ability to cause wave function collapse. In his view, conscious observers stand at the boundary between the quantum and classical realms, serving as the bridge between possibility and actuality. Wigner illustrated his ideas with a famous thought experiment now known as Wigner's friend. Imagine that Wigner's friend is isolated in a laboratory, performing a quantum measurement on a particle that could be either spin up or spin down. According to standard quantum mechanics, until the friend makes the measurement, the particle exists in a superposition of both states. But what happens from Wigner's perspective, observing the entire situation from outside the laboratory? From Wigner's viewpoint, his friend and the quantum particle together form a larger quantum system. until Wegener himself observes the results. Both the particle and his friend's measurement exist in superposition. The friend would experience a definite result, but from Wegener's perspective, the friend would be in a superposition of having measured spin up and having measured spin down. Only when Wegener gains knowledge of the result would the entire system collapse into a definite state. This thought experiment reveals the strange implications of taking consciousness seriously in quantum mechanics. It suggests that conscious observers might exist in hierarchies, with each level of consciousness capable of maintaining superpositions of lower levels until observation occurs at the highest level. Take a moment to consider what this might mean for your own experience. Every time you become aware of something, every moment of recognition or understanding, you might be participating in the fundamental process by which reality crystallizes from quantum possibilities. Your consciousness might not just be observing the world, but actively participating in its creation. Before we can understand how consciousness might interact with quantum mechanics, we need to grapple with a more fundamental question. What exactly is the wave function? This mathematical entity lies at the heart of quantum theory, yet its true nature remains one of physics' deepest mysteries. The wave function emerged in the 1920s as physicists struggled to describe the bizarre behavior of subatomic particles. Unlike classical objects that have definite positions and velocities, quantum particles seem to be smeared out across space and time, existing in multiple states simultaneously. The wave function provided a mathematical framework for describing this strange behavior, encoding the probability of finding a particle in any given state when measured. But probability of what exactly? This question has divided physicists into different camps, each with their own interpretation of what the wave function represents. Some view it as a real, physical entity that exists in the world. In this interpretation, particles genuinely are spread out across multiple locations, and the wave function describes this extended wave-like reality. When measurement occurs, this extended wave somehow collapses into a localized particle. Others argue that the wave function is purely mathematical, a tool for calculating probabilities rather than a description of physical reality. In this view, particles always have definite properties, but we simply can't know what they are until we measure them. The wave function represents our ignorance, not the true state of the particle. A third camp proposes that the wave function is real, but never actually collapses. Instead, when measurement occurs, the wave function branches into multiple parallel realities, each containing a different outcome. This many worlds interpretation suggests that all possible quantum outcomes actually happen, just in different universes that we can't access. The question of the wave function's reality becomes even more intriguing when we consider its mathematical properties. Unlike the waves we're familiar with, like sound waves or ocean waves, the wave function doesn't exist in ordinary three-dimensional space. Instead, it lives in what physicists call configuration space, a mathematical realm that can have hundreds or even thousands of dimensions for complex quantum systems. This raises a puzzling question. If the wave function is real, where exactly does it exist? It can't be located in the space around us because it requires far more dimensions than our three-dimensional world provides. Yet it somehow manages to influence the behavior of particles in our ordinary space. It's as if there's a hidden mathematical realm that governs the physical world we experience. Some physicists have proposed that the wave function exists in a kind of parallel reality, a mathematical space that's just as real as physical space, but operates according to different rules. In this view, the collapse of the wave function represents a sudden connection between this mathematical realm and our physical reality, a moment when abstract possibilities become concrete actualities. As you reflect on this idea, consider how it might relate to your own mental experience. Your thoughts and consciousness seem to exist in a realm that's connected to your physical brain, but not reducible to it. Just as the wave function might exist in a mathematical space that influences physical reality, your consciousness might exist in a mental space that interfaces with your brain in ways we don't yet understand. The relationship between the wave function and physical reality becomes even more mysterious when we consider quantum entanglement. When two particles become entangled, their wave functions become interconnected in a way that persists even when the particles are separated by vast distances. Measuring one particle instantaneously affects the state of its entangled partner, regardless of the space between them. This phenomenon, which Einstein famously called spooky action at a distance, suggests that the wave function might exist outside ordinary space and time. If entangled particles can influence each other instantaneously across arbitrary distances, then their shared wave function must somehow transcend the limitations of physical space. It exists in a realm where distance doesn't matter, where connections persist beyond the reach of any physical signal. The implications of this are staggering. If the wave function is real and exists outside ordinary space-time, then there's a level of reality that's more fundamental than the physical world we observe. This mathematical realm might be the true foundation of existence, with our three-dimensional reality emerging from its more abstract patterns. Some theorists have suggested that consciousness might naturally exist in this same mathematical realm as the wave function. Just as entangled particles can maintain instantaneous connections across space, conscious minds might be connected through this deeper level of reality. This could explain phenomena like intuition, creativity, and the mysterious ways in which conscious experiences sometimes seem to transcend the boundaries of individual brains. But we must be careful not to leap too quickly from mathematical possibility to physical reality. The wave function's mathematical properties don't necessarily tell us about its physical existence. Mathematics is incredibly powerful for describing patterns and relationships, but mathematical entities don't automatically correspond to physical things. The question of whether the wave function is real remains genuinely open, with thoughtful physicists arguing passionately on all sides. What we can say is that the wave function represents something profound about the nature of reality. Whether it's a real physical entity, a mathematical tool, or something else entirely, it captures essential features of how the quantum world behaves. It describes a realm where possibilities are more fundamental than actualities, where potential exists alongside the actual, where the boundary between what is and what might be becomes surprisingly fluid. This fluidity between possibility and actuality might be more familiar to you than you initially realize. In your own experience of consciousness, you constantly navigate between what is and what might be. Your imagination explores possibilities that don't yet exist. Your intentions reach toward potential futures. Your memory preserves actualities that no longer exist in the present moment. Perhaps consciousness naturally operates in this realm where potential and actual intermingle, making it uniquely suited to interact with quantum possibilities. As we prepare to explore how consciousness might actually interface with quantum mechanics, keep this question in mind. If the wave function represents a realm of pure possibility, and consciousness seems to naturally navigate between possibility and actuality. Might there be a deep connection between the mathematical foundation of quantum mechanics and the experiential foundation of awareness? This question will guide us as we delve deeper into the most speculative and fascinating theories about quantum consciousness. As we venture deeper into the quantum realm of consciousness, we encounter one of the most ambitious and controversial theories ever proposed: orchestrated objective reduction, or ORCHR as it's known in scientific circles. This theory, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness might literally emerge from quantum processes occurring within the microscopic structures of our brain cells. The story begins with a simple yet profound observation. When anesthesiologists administer drugs to render patients unconscious, they're not just affecting large-scale brain activity. These substances seem to target something much more fundamental, something that operates at the molecular level within individual neurons. Hameroff, working with patients day after day, began to wonder, what if consciousness isn't just a product of neural connections firing across synapses, but something that emerges from quantum processes within the cells themselves? This question led him to examine the internal architecture of neurons, those specialized cells that form the basic units of our nervous system. Inside each neuron, he discovered a fascinating network of protein structures called microtubules. These aren't just structural supports like the scaffolding in a building. They're dynamic, complex systems that help organize the cell's internal activities and regulate the flow of information throughout the neuron. Picture these microtubules as incredibly tiny tubes, thousands of times thinner than a human hair, made up of protein subunits called tubulins. Each tubulin can exist in different states, almost like molecular switches that can be either on or off. But here's where the story becomes truly intriguing. Hameroff proposed that these tubulin proteins might be capable of existing in quantum superposition, simultaneously in multiple states until some process causes them to collapse into definite configurations. Imagine a vast network of these molecular switches, millions of them within each neuron, billions of neurons throughout your brain, all potentially operating according to quantum principles. In this view, your consciousness wouldn't emerge from the classical firing of neurons alone, but from quantum computations occurring within this microscopic realm, orchestrated by the cellular structures that most neuroscientists had previously considered mere housekeeping elements. Roger Penrose brought a physicist's perspective to this biological insight. He had been grappling with a different but related question: the nature of mathematical understanding and consciousness. How is it that human minds can grasp mathematical truths that seem to transcend computational algorithms? How do we experience sudden insights, creative breakthroughs, or moments of understanding that appear to come from beyond logical, step-by-step reasoning? Penrose argued that consciousness must involve non-computational processes, something that goes beyond what even the most sophisticated classical computer could achieve. He proposed that quantum mechanics, with its inherent indeterminacy and its connection to the fundamental structure of space-time itself, might provide the missing ingredient. When Hameroff approached him with the microtubule hypothesis, Penrose saw an opportunity to ground his abstract ideas about consciousness in the concrete biology of the brain. Together, they developed the ORCHR theory, which proposes that microtubules within neurons can maintain quantum coherence long enough to perform meaningful quantum computations. These computations would culminate in what Penrose calls objective reduction events, moments when quantum superpositions collapse not because of external measurement, but due to the inherent instability of space-time itself when quantum systems reach a certain threshold of complexity. In this remarkable vision, each moment of conscious awareness corresponds to an orchestrated collapse of quantum superpositions within networks of microtubules throughout the brain. These aren't random collapses, but organized events that integrate information across vast networks of neurons, creating the unified experience of consciousness that you're having right now as you listen to these words. The theory suggests something even more profound, that consciousness might be connected to the fundamental geometry of space-time itself. According to Penrose's interpretation of quantum mechanics, the collapse of wave functions isn't just a random process, but one that's influenced by objective features of reality embedded in the structure of space and time at the smallest scales. If consciousness emerges from these collapse events, then your awareness might be directly connected to the deepest levels of physical reality. Take a moment to consider what this might mean for your subjective experience. Every thought, every sensation, every moment of recognition or understanding might correspond to quantum processes occurring within the microscopic architecture of your brain. Your consciousness wouldn't be separate from the physical world, but intimately connected to quantum processes that bridge mind and matter at the most fundamental level. Of course, this theory faces significant challenges and skepticism from the scientific community. The primary objection concerns decoherence, the process by which quantum systems lose their quantum properties when they interact with their environment. The brain is warm, wet, and incredibly noisy from a quantum perspective. Most physicists argue that quantum coherence would be destroyed almost instantly in such an environment, long before it could contribute to consciousness. Critics have calculated that quantum states in the brain would decohere in tiny fractions of a second, far too quickly to influence the neural processes that underlie conscious experience. The brain, they argue, should be thought of as a classical system, governed by the same physics that describes the everyday objects around us, not the strange quantum realm of superposition and entanglement. However, recent discoveries in quantum biology have begun to challenge these assumptions. Scientists have found quantum effects operating in photosynthesis, the process by which plants convert sunlight into energy. They've discovered quantum coherence in the navigation systems of birds, which appear to use quantum entanglement to detect magnetic fields. These biological systems somehow manage to maintain quantum effects despite operating in warm, noisy environments similar to the brain. These discoveries suggest that evolution might have found ways to protect and even exploit quantum effects in biological systems. Perhaps life itself has developed mechanisms that we don't yet understand for preserving quantum coherence in environments that physicists assumed would destroy it. If so, the brain might indeed be capable of supporting the kind of quantum processes that OR proposes. Recent experimental work has begun to probe these possibilities directly. Researchers have detected unusual optical properties in microtubules that might be signatures of quantum effects. They found evidence of what's called superradiance in networks of tryptophan molecules, the same kind of molecules that are found in the tubulin proteins that make up microtubules. While this research is still in its early stages, it suggests that quantum effects might be more robust in biological systems than previously thought. As you reflect on these ideas, notice how they might change your relationship to your own consciousness. If the Orch-or theory is correct, your awareness isn't just a byproduct of brain activity, but a fundamental feature of how the universe processes information. Your thoughts and experiences would be directly connected to the quantum processes that govern reality at its deepest level. This perspective suggests a profound unity between mind and cosmos. Rather than being isolated observers looking out at an external world, we would be integral participants in the universe's ongoing process of self-organization and self-awareness. Our consciousness wouldn't be separate from nature, but one of the ways that nature becomes conscious of itself. The relationship between consciousness and quantum mechanics reaches its most profound expression in what physicists call the measurement problem. This isn't just an abstract theoretical puzzle, it's a mystery that strikes at the heart of what we mean by reality itself. Every time you become aware of something, every moment of conscious observation, you might be participating in the most fundamental process in the universe, the transformation of quantum possibilities into actual experience. Let's begin with a thought experiment that illuminates the strangeness of quantum measurement. Imagine you're looking at a quantum particle through a sophisticated detector. Before you look, quantum mechanics tells us that the particle exists in a superposition of multiple states, perhaps spinning both clockwise and counterclockwise simultaneously. The mathematics describes this perfectly, giving us precise probabilities for what we might observe. But here's the mystery. The moment you actually observe the particle, something dramatic happens. The superposition vanishes, and the particle appears to be spinning in just one direction. The wave function, which had been describing multiple possibilities, suddenly collapses into a single, definite state. Yet the equations of quantum mechanics don't actually describe this collapse. They show wave functions evolving smoothly over time, never suddenly jumping from multiple states to a single state. This presents us with a fundamental puzzle. If the equations don't describe collapse, what causes it? When exactly does a quantum system stop being quantum and start being classical? Is there something special about the act of observation that transforms possibilities into actualities? The traditional answer, enshrined in what's called the Copenhagen interpretation, simply asserts that measurement causes collapse without explaining the mechanism. A classical measuring device interacts with a quantum system, and somehow this interaction creates a definite outcome. But this explanation pushes the mystery back one step without solving it. What makes a measuring device classical rather than quantum? Where exactly does the quantum realm end and the classical world begin? Some physicists have proposed that consciousness itself provides the answer. In this interpretation, the boundary between quantum and classical isn't determined by the size or complexity of physical systems, but by the presence of conscious observation. Only when a conscious observer becomes aware of the measurement result does the wave function actually collapse. Until that moment of conscious recognition, the entire system, including the measuring apparatus, remains in quantum superposition. This consciousness causes collapse interpretation leads to fascinating implications. It suggests that reality, at its most fundamental level, is participatory. The universe doesn't simply exist independently of observers, but requires conscious awareness to actualize specific outcomes from quantum possibilities. In this view, consciousness isn't just passively observing reality, it's actively participating in its creation. Consider what this might mean for your own experience right now. As you become aware of each word, each idea, each moment of understanding, you might be collapsing quantum wave functions in your brain, transforming neural possibilities into definite thoughts and experiences. Your consciousness wouldn't just be receiving information about the world, it would be participating in the ongoing process by which indefinite possibilities become definite realities. This interpretation finds support in some of the strangest experiments in quantum physics. In delayed choice experiments, scientists can decide whether to measure a quantum particle's wave-like or particle-like properties, even after the particle has already interacted with the experimental apparatus. Remarkably, the particle seems to retroactively behave in a way that's consistent with whatever measurement the scientists eventually choose to make. It's as if the future decision about how to observe the particle somehow influences its past behavior. Even more intriguingly, quantum eraser experiments show that scientists can restore quantum interference patterns by erasing information about which path a particle took, even after that information has been recorded. These experiments suggest that the physical act of measurement isn't what causes wave function collapse, but rather the potential for gaining information about the quantum system. When that information is erased, the quantum behavior returns. These phenomena hint at a deep connection between information, consciousness, and quantum mechanics. They suggest that what matters for wave function collapse isn't the physical interaction between measuring devices and quantum systems, but the flow of information into conscious awareness. The universe seems to care not just about what happens, but about what can be known about what happens. As you contemplate these ideas, take a moment to notice your own process of observation and awareness. When you shift your attention from one thing to another, when you become conscious of a thought or sensation that was previously in the background of your experience, you're engaging in the same kind of process that might cause quantum wave functions to collapse. The act of conscious observation, whether directed outward toward the physical world or inward toward your own mental states, might be one of the most fundamental activities in the universe. This perspective suggests a profound responsibility that comes with consciousness. If conscious observation really does play a role in actualizing reality from quantum possibilities, then every moment of awareness is a creative act. You're not just passively receiving information about a pre-existing world, but actively participating in the ongoing creation of reality itself. The implications extend beyond individual consciousness to collective awareness. If consciousness influences quantum outcomes, then the combined awareness of all conscious beings might be shaping reality on a cosmic scale. The thoughts, observations, and awareness of billions of conscious entities might be continuously influencing the quantum processes that underlie all physical phenomena. Some interpretations suggest that this participatory universe has always been the case, even before conscious life evolved. In this view, consciousness isn't something that emerged accidentally from complex matter, but a fundamental feature of reality that was present from the beginning. The universe might be inherently conscious at some level, with biological consciousness representing a localized intensification of a more universal awareness. This idea resonates with certain interpretations of quantum mechanics that propose consciousness-like properties even for simple quantum systems. In integrated information theory, any system that integrates information has some degree of consciousness. Even individual atoms and molecules would possess tiny amounts of awareness. This suggests that consciousness isn't unique to brains, but a fundamental feature of how the universe processes information. If you find these ideas stretching your conception of reality, you're not alone. Many physicists find consciousness-based interpretations of quantum mechanics deeply unsettling, not because they're necessarily wrong, but because they challenge our most basic assumptions about the nature of objectivity and the independence of the physical world from conscious observers. Yet these interpretations persist because they address genuine puzzles in quantum mechanics that more conventional approaches struggle to explain. The measurement problem remains unsolved by purely physical theories. The strange correlations observed in quantum experiments continue to suggest that reality is far more interconnected and observer-dependent than our everyday experience suggests. As we prepare to explore how these quantum consciousness theories might be tested and what their implications might be for our understanding of mind and reality, remember that we're venturing into territory where science meets philosophy, where precise mathematics encounters the deepest questions about the nature of existence. These are not settled questions, but living mysteries that continue to evolve as our understanding deepens. The most remarkable aspect of consciousness-based interpretations of quantum mechanics is that they're not purely philosophical speculation. Despite their seemingly mystical implications, these theories make specific predictions that can, in principle, be tested through carefully designed experiments. We're living through a fascinating period when some of the deepest questions about consciousness and reality are beginning to move from the realm of theory into the laboratory. Consider the challenge facing researchers who want to test whether consciousness influences quantum systems. How do you design an experiment that can distinguish between the effects of conscious observation and the purely physical effects of measurement apparatus? How do you isolate the role of awareness from the mechanical interactions that occur during any measurement process? One approach involves what physicists call quantum Zeno experiments. The quantum Zeno effect demonstrates that frequent observation of a quantum system can actually freeze its evolution, preventing it from changing states. If consciousness plays a special role in quantum measurement, then conscious observation might produce different Zeno effects compared to unconscious monitoring by automatic devices. Researchers have begun designing experiments where human observers consciously monitor quantum systems, comparing the results to identical systems monitored only by unconscious computers. While the results so far remain inconclusive, these experiments represent a genuine attempt to test whether consciousness has any special influence on quantum processes. More ambitious experiments are being planned using quantum computers, systems that can maintain quantum superpositions under carefully controlled conditions. If consciousness really does cause wave function collapse, then having conscious observers focus their attention on quantum computer operations might influence the system's behavior in measurable ways. These experiments would need to control for all possible physical influences while isolating the potential effects of conscious attention. The orchestrated objective reduction theory has inspired its own experimental program. Researchers funded by organizations like the Templeton World Charity Foundation are directly testing whether microtubules in neurons can maintain quantum coherence under physiological conditions. They're examining whether anesthetics, which eliminate consciousness, specifically disrupt quantum processes in microtubules while leaving other cellular functions intact. Recent studies have detected unusual optical properties in microtubules that might indicate quantum effects. Scientists have confirmed the existence of superradiance, a quantum phenomenon, in networks of tryptophan molecules like those found in neural microtubules. While these findings don't prove that consciousness emerges from quantum processes, they suggest that quantum effects might be more prevalent in biological systems than previously thought. As you consider these experimental approaches, notice how they represent a fascinating convergence of subjective and objective investigation. Scientists are trying to measure consciousness itself, to quantify awareness and test its influence on physical systems. This represents a dramatic departure from the traditional scientific approach of studying consciousness only through its external manifestations. The experimental investigation of consciousness quantum connections faces unique methodological challenges. Unlike other areas of physics, where researchers can study systems independently of observers, consciousness experiments necessarily involve the very phenomenon they're trying to measure. The conscious awareness of the experimenters themselves becomes part of the experimental system. This creates what philosophers call the hard problem of consciousness research. How do you objectively study something that is inherently subjective? How do you measure the qualitative aspects of conscious experience using quantitative scientific methods? These challenges have led some researchers to develop new experimental paradigms that acknowledge the participatory nature of consciousness research. One promising approach involves what's called first-person science, where trained contemplatives learn to observe their own consciousness with scientific precision. These practitioners develop the ability to notice subtle changes in their awareness, to detect the arising and passing of thoughts and sensations with extraordinary sensitivity. When such trained observers participate in quantum consciousness experiments, they might be able to provide data about their subjective states that correlates with quantum measurements in ways that untrained subjects cannot. This approach draws inspiration from the contemplative traditions that have been studying consciousness systematically for thousands of years. Meditation practices, for instance, involve learning to observe the mind with the same kind of careful attention that scientists bring to physical phenomena. Advanced meditators report experiences of consciousness that seem to transcend the ordinary boundaries of individual awareness, states that might provide insights into the quantum nature of mind. Some researchers have proposed that meditation itself might involve quantum processes. The states of expanded awareness reported by experienced meditators might correspond to increased quantum coherence in neural networks. The sense of unity and interconnectedness that characterizes deep meditative states might reflect direct experience of quantum entanglement between different regions of the brain, or even between individual consciousness and larger quantum fields. If you've ever experienced meditative states yourself, take a moment to recall their qualitative characteristics. The sense of spaciousness, the feeling that the boundaries of individual selfhood become more fluid, the experience of awareness itself as something more fundamental than thoughts or sensations. These qualities might provide subjective access to the same quantum realm that physicists study through mathematical equations and laboratory instruments. However, we must be careful not to conflate subjective experiences with objective quantum phenomena. The fact that meditation produces states of expanded awareness doesn't necessarily mean that these states involve quantum processes in any scientifically meaningful sense. Correlation doesn't imply causation, and subjective reports, however profound, don't constitute scientific evidence without independent verification. This caution is particularly important when considering claims about quantum consciousness that go beyond what current scientific evidence supports. While it's fascinating to explore connections between consciousness and quantum mechanics, we must distinguish between legitimate scientific speculation and unfounded assertions about the power of consciousness to influence physical reality through quantum effects. The scientific investigation of consciousness quantum connections remains in its early stages. Most of the evidence is suggestive rather than conclusive, opening possibilities rather than proving theories. The field requires the kind of patient, careful investigation that characterizes good science, combined with openness to phenomena that might challenge conventional assumptions about the nature of mind and reality. What makes this research particularly exciting is its potential to bridge the gap between subjective and objective knowledge. If consciousness really does interface with quantum processes, then the scientific study of mind might require new methodologies that integrate first-person and third-person approaches. We might need to develop ways of investigating consciousness that honor both its subjective reality and its potential physical correlates. As we continue exploring these possibilities, remember that we're participating in one of the most ambitious scientific investigations ever undertaken, the attempt to understand consciousness itself. Whether or not consciousness turns out to involve quantum processes, the very fact that we can ask these questions, design experiments to test them, and contemplate their implications represents something remarkable about the universe we inhabit. The cosmos has evolved systems like us, capable of studying themselves. Through our investigations of consciousness and quantum mechanics, the universe is literally becoming aware of its own deepest structures. We are the means by which reality studies itself, the process by which the cosmos develops self-understanding. In that sense, regardless of what future experiments reveal, consciousness already plays a fundamental role in the universe's ongoing process of self-discovery. As we venture deeper into the relationship between consciousness and quantum reality, we encounter what might be the most perplexing question in modern science. If consciousness plays a role in quantum measurement, what was happening in the universe before conscious observers evolved? This puzzle, sometimes called the consciousness before consciousness problem, reveals the profound challenges that arise when we take seriously the idea that awareness might be fundamental to reality itself. Consider the early universe, that primordial epoch when stars were just beginning to form from clouds of hydrogen and helium. According to our best understanding of cosmic evolution, conscious life wouldn't emerge for billions of years. Yet quantum processes were occurring throughout this ancient cosmos. Wave functions were presumably collapsing, and definite outcomes were emerging from quantum possibilities. If consciousness causes collapse, what was collapsing all those wave functions in the absence of conscious observers? This paradox has led some physicists to propose radical solutions. Perhaps consciousness isn't something that emerges from complex matter, but rather a fundamental feature of the universe that was present from the very beginning. In this view, the capacity for awareness might be built into the fabric of reality itself, existing even in the simplest quantum systems. This idea finds expression in what philosophers call panpsychism, the notion that consciousness is a basic property of matter, like mass or electric charge. Just as every particle has a certain mass, and every charged particle creates an electric field, perhaps every quantum system possesses some rudimentary form of awareness. This wouldn't be the rich, complex consciousness that you experience as you listen to these words, but rather a primitive sensitivity, a basic capacity for information processing and response. Take a moment to consider what this might mean for your relationship to the physical world around you. If panpsychism is correct, then consciousness wouldn't be limited to biological brains. The atoms in your body, the photons of light illuminating your room, even the quantum fields that permeate empty space might possess some form of rudimentary awareness. You wouldn't be an isolated island of consciousness in a dead universe, but rather a complex orchestration of countless microscopic conscious entities. Some interpretations of quantum mechanics lend support to this perspective. Integrated information theory, developed by neuroscientist Giulio Tononi, proposes that consciousness corresponds to integrated information, a mathematical quantity that can be calculated for any physical system. According to this framework, any system that integrates information, from simple particles to complex brains, possesses some degree of consciousness proportional to the amount of information it integrates. In the IIT framework, even individual atoms would have tiny amounts of consciousness, and the rich awareness you experience emerges from the integration of information across billions of neurons in your brain. This provides a potential solution to the early universe problem. Quantum wave functions could collapse due to the primitive consciousness present in quantum systems themselves, without requiring the complex awareness found in biological organisms. But this solution raises its own puzzles. If consciousness is truly fundamental, how do we explain the apparent emergence of complex awareness from simpler components? How does the primitive consciousness of individual particles give rise to the unified experience of selfhood that characterizes human awareness? These questions push us toward even more speculative territory, where the boundaries between physics, philosophy, and metaphysics begin to blur. Some researchers have proposed that consciousness might exist in a hierarchical structure, with different levels of awareness corresponding to different scales of organization. Individual particles might possess minimal consciousness, molecules slightly more, cells even more, and complex brains, the rich integrated awareness that we recognize as human consciousness. In this view, your consciousness wouldn't replace the consciousness of your constituent particles, but rather represent a higher level organization of their more primitive awareness. This hierarchical perspective suggests that consciousness might be fractal in nature, displaying similar patterns at different scales of organization. Just as a coastline reveals similar complexity, whether viewed from orbit or through a microscope, consciousness might exhibit nested levels of awareness from the quantum to the cosmic scale. Your individual awareness would be embedded within larger patterns of consciousness that you normally don't perceive directly. As you reflect on these ideas, notice how they might change your sense of isolation or separateness from the world around you. If consciousness really is fundamental and hierarchical, then your awareness isn't confined within the boundaries of your skull, but extends outward into the quantum processes that connect you to the rest of reality. The photons entering your eyes carry not just information, but perhaps traces of awareness from the atoms that emitted them. The air you breathe might be suffused with primitive forms of consciousness that become temporarily integrated into your own awareness. These speculative ideas find some support in the strange correlations observed in quantum entanglement experiments. When two particles become entangled, they maintain instantaneous connections regardless of the distance separating them. Measuring one particle immediately affects its entangled partner, as if they share a form of non-local awareness that transcends the limitations of space and time. Some interpretations suggest that entanglement might represent a kind of primitive communication or shared consciousness between quantum systems. When particles become entangled, They might be establishing channels of awareness that allow them to coordinate their behaviour across arbitrary distances. This wouldn't be communication in any conventional sense, but rather a direct sharing of conscious states that bypasses the need for signals travelling through space. If entanglement really does involve shared consciousness, then the universe might be far more interconnected than we typically imagine. Every quantum interaction might be creating temporary bonds of awareness between particles, weaving the cosmos together into a vast network of primitive consciousness. Your own awareness would emerge from this cosmic web, representing a localized intensification of a more universal conscious field. However, we must be extremely careful about making such claims without solid scientific evidence. The fact that quantum mechanics reveals strange correlations and non-local connections doesn't necessarily mean that these phenomena involve consciousness in any meaningful sense. It's entirely possible that quantum entanglement and other quantum phenomena operate according to purely physical principles that have nothing to do with awareness or information processing. The temptation to find consciousness in quantum mechanics might reflect our deep human need to feel connected to the universe around us. We're conscious beings trying to understand consciousness, and it's natural that we might project our own awareness onto the quantum processes we study. The anthropic bias in consciousness research is particularly strong because we can only investigate consciousness from within the conscious perspective itself. This is why the experimental programs we discussed earlier are so important. Rather than relying on philosophical speculation or mathematical elegance, we need careful empirical investigation to determine whether consciousness really does play any role in quantum processes. The experiments being conducted on microtubules, quantum computers, and conscious observation of quantum systems represent genuine attempts to test these ideas rather than simply assume their truth. What makes these questions particularly fascinating is their implications for our understanding of scientific objectivity itself. Traditional science assumes that reality exists independently of observers, that the universe would continue to operate according to the same laws even if no conscious beings existed to study it. But if consciousness plays a fundamental role in quantum mechanics, then this assumption might need to be revised. The participatory universe hypothesis suggests that reality might be inherently subjective, shaped by the conscious observations that bring it into being. This doesn't mean that reality is arbitrary or that consciousness can manipulate physical laws through wishful thinking. Rather, it suggests that the boundary between subjective and objective might be more fluid than we typically assume, with conscious observers playing an active role in actualizing specific outcomes from quantum possibilities. If you find yourself drawn to these ideas, take a moment to notice your own participation in this ongoing process of reality formation. Every moment of conscious awareness, every act of attention or recognition might represent your contribution to the universe's continuous process of self-actualization. You're not just passively observing a pre-existing world, but actively participating in its ongoing creation through the very act of conscious observation. Yet even as we explore these possibilities, we must maintain a healthy skepticism about claims that go beyond what current scientific evidence supports. The universe is under no obligation to conform to our desires for meaning or connection. Reality might be far stranger than we imagine, but it might also be more mundane than our speculations suggest. What we can say with confidence is that the investigation of consciousness and quantum mechanics continues to reveal the profound mystery at the heart of existence itself. Whether or not consciousness plays a fundamental role in quantum processes, the very fact that we can contemplate these questions represents something remarkable about the universe we inhabit. Through our investigations, the cosmos is literally studying itself, developing ever deeper understanding of its own nature and possibilities. The most formidable obstacle facing quantum theories of consciousness isn't philosophical skepticism, but a fundamental physical process called decoherence. This phenomenon represents nature's own critique of quantum consciousness hypotheses, and understanding it is crucial for evaluating whether quantum effects could realistically survive in the warm, wet, noisy environment of the human brain. Imagine a quantum system existing in perfect isolation, perhaps a single particle floating in the vacuum of deep space. In such pristine conditions, the particle could maintain its quantum superposition indefinitely, existing in multiple states simultaneously without any external interference. The wave function describing this system would evolve smoothly according to Schrödinger's equation, never collapsing unless deliberately measured. But now imagine what happens when this isolated system begins to interact with its environment. Every photon that bounces off the particle, every collision with another particle, every interaction with electromagnetic fields gradually destroys the quantum coherence. The delicate superposition states become entangled with the surrounding environment, and the quantum information leaks away into the vastness of space. This process of environmental interaction and information loss is what physicists call decoherence. The mathematics of decoherence are unforgiving. In most environments, quantum coherence is destroyed incredibly quickly, often in tiny fractions of a second. The warmer and more interactive the environment, the faster decoherence occurs. And few environments are as warm and interactive as the interior of a living brain. Consider the conditions inside your skull as you listen to these words. Your brain operates at a temperature of about 37 degrees Celsius, nearly 100 degrees above the temperatures used in most quantum physics laboratories. It's filled with water molecules in constant thermal motion, ions flowing across cell membranes, electromagnetic fields generated by neural activity. From a quantum physicist's perspective, it's an incredibly hostile environment for maintaining the delicate coherence required for quantum computation. Critics of quantum consciousness theories have performed detailed calculations showing that quantum coherence in neural microtubules would be destroyed in less than a trillionth of a second under physiological conditions. This is far too short a time for quantum processes to influence the neural activity that underlies conscious experience, which operates on timescales of milliseconds or longer. Take a breath and notice how this challenge might feel initially discouraging if you're drawn to the idea of quantum consciousness. The cold mathematics of decoherence seem to rule out any meaningful role for quantum effects in biological systems. For decades, this appeared to be the final word on the subject, relegating quantum biology to the realm of impossible speculation. But science has a wonderful way of surprising us. In the past 2 decades, researchers have discovered quantum effects operating in biological systems throughout the natural world, thriving in conditions that theoretical calculations suggested should destroy quantum coherence almost instantly. These discoveries have revolutionized our understanding of what's possible in biological quantum mechanics. The first major breakthrough came in the study of photosynthesis, the process by which plants convert sunlight into chemical energy. Scientists discovered that the initial stages of photosynthesis involve quantum coherence, with energy from absorbed photons existing in superposition across multiple pathways simultaneously. This allows the energy to explore all possible routes through the photosynthetic apparatus and select the most efficient path to the reaction center. What makes this discovery remarkable is that photosynthesis occurs under conditions similar to those found in neural tissue: warm temperatures, aqueous environments, and constant molecular motion. Yet somehow, the photosynthetic machinery has evolved to not just tolerate these conditions, but to use them to enhance quantum coherence rather than destroy it. Further research revealed quantum effects in other biological systems that seemed equally unlikely to support them. The magnetic compass used by migrating birds appears to rely on quantum entanglement in cryptochrome proteins within their retinas. These proteins can detect the weak magnetic field of Earth through quantum processes that remain coherent despite operating in the warm, noisy environment of living cells. As you contemplate these discoveries, notice how they might shift your perspective on what's possible in biological systems. Evolution has had billions of years to experiment with different mechanisms for processing information and energy. If quantum effects provide advantages for biological function, natural selection would have powerful incentives to find ways to protect and exploit them. Recent theoretical work has begun to explain how biological systems might achieve this seemingly impossible feat. Rather than fighting against environmental noise, some biological quantum systems appear to use that noise constructively. The random fluctuations that destroy quantum coherence in artificial systems might actually help biological systems maintain it through a process called environmentally assisted quantum transport. In this counterintuitive mechanism, environmental noise provides just the right amount of disturbance to prevent quantum systems from getting trapped in inefficient local configurations. The noise acts like a gentle shake that helps the system explore different quantum pathways and find optimal solutions. It's as if biological systems have learned to surf on the waves of thermal noise, rather than being overwhelmed by them. This discovery suggests that the warm, noisy conditions inside the brain might not be obstacles to quantum processing, but rather the optimal environment for certain types of quantum computation. The constant activity of neural networks, the flow of ions across membranes, the thermal fluctuations of protein structures, all of these might contribute to maintaining rather than destroying quantum coherence in neural microtubules. However, we must be careful not to leap too quickly from these exciting discoveries to conclusions about consciousness. The fact that quantum effects can survive in biological systems doesn't automatically prove that they play a role in consciousness or cognitive function. Demonstrating quantum coherence in photosynthesis or bird navigation is very different from showing that quantum processes contribute to subjective experience or conscious awareness. The research on quantum effects in microtubules remains preliminary and controversial. While some studies have detected unusual optical properties that might indicate quantum phenomena, others have failed to find clear evidence of quantum coherence under physiological conditions. The scientific community remains divided on whether microtubules can realistically support the kind of quantum processing proposed by Orchestrated theory. Recent experiments have attempted to bridge this gap by studying the effects of anesthetics on potential quantum processes in neural tissue. If consciousness really does emerge from quantum computations in microtubules, then anesthetic drugs should specifically disrupt these quantum processes while leaving other cellular functions intact. Some preliminary results suggest this might be happening, but the evidence remains far from conclusive. As you reflect on these ongoing investigations, consider how they represent a fascinating example of science pushing against its own limitations. The discovery of quantum effects in biological systems has forced physicists to reconsider fundamental assumptions about decoherence and environmental noise. What seemed impossible based on first principles has turned out to be not just possible, but widespread in nature. This doesn't mean that quantum consciousness theories are correct, but it does mean they deserve serious scientific consideration rather than dismissal based on theoretical objections alone. The biological world has proven to be far more quantum than anyone expected, and the human brain might be no exception. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The implications of quantum biology extend beyond consciousness research to our understanding of life itself. If biological systems routinely exploit quantum effects for enhanced efficiency and performance, then life might be fundamentally quantum mechanical rather than classical. The boundary between living and non-living systems might correspond to the emergence of quantum information processing capabilities. This perspective suggests that consciousness might not be unique among biological phenomena, but rather one example of life's general ability to harness quantum mechanics for complex information processing. Your awareness might represent the subjective experience of quantum computations that are occurring throughout your body at the cellular level, not just in your brain. These ideas remain highly speculative, but they point toward a vision of life that is far more integrated with the fundamental laws of physics than we previously imagined. Rather than being classical machines built from quantum components, living systems might be quantum entities that have learned to create the appearance of classical behavior when necessary for survival and function. As we continue exploring these possibilities, remember that we're witnessing the emergence of an entirely new field of science. Quantum biology is still in its infancy, with new discoveries regularly challenging our assumptions about what's possible at the intersection of quantum mechanics and living systems. The next decade will likely bring revelations that further transform our understanding of life, consciousness, and the quantum nature of reality itself. The greatest challenge facing quantum consciousness research isn't theoretical objection or mathematical complexity, but something more fundamental. How do you scientifically study something that might be inherently subjective? How do you design experiments to test whether consciousness influences quantum processes when consciousness itself remains one of science's greatest mysteries? This methodological puzzle has led researchers to develop some of the most ingenious experiments in the history of science. These investigations push the boundaries of what we can measure, test, and know about the relationship between mind and matter. They represent humanity's attempt to turn consciousness itself into an object of rigorous scientific study. Consider the experimental approach known as quantum random number generation studies. Researchers generate truly random sequences of numbers using quantum processes, then ask human subjects to mentally influence these sequences towards specific patterns or outcomes. If consciousness can influence quantum processes, then focused mental intention might be able to bias these supposedly random sequences in measurable ways. The results of such experiments remain controversial and inconclusive. Some studies report small but statistically significant effects, suggesting that conscious intention might indeed influence quantum random number generators. Others find no effects beyond what would be expected by chance alone. The scientific community remains deeply divided about the interpretation of these results. As you consider these experiments, notice the profound challenges they face. Unlike other areas of physics, where researchers can study systems in isolation from observers, consciousness experiments necessarily involve the very phenomenon they're trying to measure. The conscious awareness of the experimenters, the expectations of the subjects, the cultural context of the research, all become part of the experimental system in ways that are difficult to control or quantify. This has led some researchers to develop double-blind protocols where neither the experimenters nor the subjects know which quantum systems are being targeted for mental influence. Computer systems randomly select target generators and record results automatically, with human involvement minimized until the data analysis phase. These protocols attempt to eliminate psychological biases and expectation effects while preserving the potential for consciousness to influence quantum processes. Another innovative approach involves studying the quantum mechanical properties of biological systems directly. Rather than asking whether consciousness influences external quantum processes, these experiments investigate whether quantum effects occur within the neural systems that might underlie consciousness itself. Researchers examine brain tissue samples under carefully controlled conditions, looking for evidence of quantum coherence in microtubules and other cellular structures. Recent studies have detected unusual optical properties in neural microtubules that might indicate quantum phenomena. Scientists have observed what appears to be superradiance, a collective quantum effect, in networks of tryptophan molecules found within these cellular structures. While these findings don't prove that consciousness emerges from quantum processes, they suggest that the biological substrate of consciousness might be more quantum mechanical than previously thought. The investigation of anesthetic effects provides another promising experimental avenue. If consciousness really does emerge from quantum computations in neural microtubules, then anesthetic drugs should specifically disrupt these quantum processes while leaving other cellular functions relatively intact. This creates a testable prediction. Anesthetics should have measurable effects on quantum coherence in neural tissue. Preliminary experiments along these lines have produced intriguing but inconclusive results. Some studies suggest that anesthetic concentrations do indeed affect quantum properties of neural microtubules, but the effects are subtle and difficult to distinguish from other cellular changes. The research remains in early stages, with definitive conclusions still years away. Take a moment to appreciate the extraordinary difficulty of this experimental program. Researchers are attempting to measure quantum effects in living tissue to detect consciousness-related processes at the molecular level, to bridge the gap between subjective experience and objective measurement. These investigations push the limits of current technology and methodology in ways that few other scientific endeavours have attempted. The challenges extend beyond technical difficulties to fundamental questions about the nature of scientific objectivity. Traditional science assumes that reality exists independently of observers, that experimental results should be reproducible regardless of who conducts the experiments. But if consciousness plays a fundamental role in quantum processes, then this assumption might need to be reconsidered. Some researchers have proposed that consciousness experiments might inherently involve what philosophers call observer effects, where the consciousness of the experimenters themselves influences the outcomes being studied. This doesn't mean that experimental results are arbitrary or that consciousness can manipulate physical laws through wishful thinking. Rather, it suggests that the boundary between observer and observed might be more fluid in consciousness research than in other areas of science. This possibility has led to the development of participatory research methodologies that acknowledge the role of consciousness in the experimental process. Rather than trying to eliminate the observer, these approaches attempt to study the observer-observed relationship as a legitimate object of scientific investigation. This represents a significant departure from traditional scientific methodology, one that some researchers embrace while others view with deep skepticism. The field has also been enriched by collaborations with contemplative practitioners who have spent decades studying consciousness through direct experience. Advanced meditators, for instance, can provide detailed first-person reports about subtle changes in awareness that might correlate with quantum measurements in ways that untrained subjects cannot. This integration of contemplative and scientific methodologies opens new possibilities for consciousness research. However, we must be extremely cautious about interpreting preliminary results as definitive evidence for quantum consciousness theories. The history of consciousness research is littered with exciting findings that failed to replicate when subjected to more rigorous investigation. The human tendency to find patterns and meaning in random data is particularly strong when studying phenomena as personally meaningful as consciousness itself. The most promising experimental approaches combine multiple complementary methodologies rather than relying on any single type of evidence. Studies that examine quantum effects in neural tissue, test the influence of anesthetics on these effects, and correlate the results with measures of consciousness provide stronger evidence than any individual approach alone. Recent technological advances are opening new experimental possibilities that were unimaginable just a few years ago. Quantum sensors capable of detecting incredibly subtle magnetic and electric fields might be able to measure quantum processes in living neural tissue with unprecedented precision. Brain imaging techniques are becoming sensitive enough to detect the metabolic signatures of quantum computations if they occur in significant quantities. As you reflect on these experimental frontiers, consider how they represent humanity's attempt to understand its own deepest nature through the methods of empirical science. We are conscious beings studying consciousness, aware entities investigating awareness itself. This creates unique challenges and opportunities that don't exist in other areas of scientific research. The experimental investigation of quantum consciousness remains in its earliest stages, with far more questions than answers. Most of the evidence is suggestive rather than conclusive, opening possibilities rather than proving theories. The field requires patience, rigor, and openness to phenomena that might challenge our most basic assumptions about the nature of mind and reality. What makes this research particularly exciting is its potential to bridge ancient philosophical questions with cutting-edge scientific methodology. For thousands of years, human beings have wondered about the nature of consciousness, the relationship between mind and matter, the possibility that awareness plays a fundamental role in reality itself. Now, for the first time in history, we have the tools to begin investigating these questions through controlled experiments, rather than philosophical speculation alone. As we draw together the threads of quantum consciousness research, we arrive at a profound question that extends far beyond the laboratory and into the deepest philosophical implications of existence itself. If consciousness really does play a fundamental role in quantum mechanics, what would this mean for our understanding of reality, free will, and our place in the cosmos? The implications are staggering in their scope and profundity. A consciousness-based interpretation of quantum mechanics would suggest that reality is not simply a collection of objects existing independently in space and time, but rather a participatory process in which conscious observation plays an active role in determining what becomes actual from the realm of quantum possibilities. This participatory universe hypothesis challenges one of the most basic assumptions of classical science: the notion that reality exists objectively, independent of observers. Instead, it suggests that the universe might be inherently subjective, shaped by the conscious observations that bring it into being. This doesn't mean that reality is arbitrary, or that consciousness can manipulate physical laws through wishful thinking, but rather that the boundary between subjective and objective might be more fluid than we typically assume. Consider what this might mean for your understanding of your own agency and responsibility in the world. If conscious observation really does play a role in actualizing reality from quantum possibilities, then every moment of awareness represents a creative act. You wouldn't be merely a passive observer of a pre-existing world, but an active participant in its ongoing creation through the very act of conscious observation. This perspective resonates with certain interpretations of free will that have puzzled philosophers for centuries. Classical physics seem to suggest that the universe operates like a vast machine, with every event determined by prior causes stretching back to the beginning of time. In such a deterministic universe, free will becomes an illusion, a subjective experience that masks the underlying mechanical causation governing all events. But quantum mechanics introduces genuine indeterminacy into the physical world. Quantum events are not determined by prior causes in the classical sense, but emerge probabilistically from the collapse of wave functions. If consciousness plays a role in this collapse process, then conscious choices might represent genuine causal influences on physical reality rather than mere subjective experiences of predetermined events. This doesn't solve the free will problem entirely, but it does open conceptual space for human agency that didn't exist in classical physics. Your decisions and choices might not be reducible to purely physical processes, but might instead represent the influence of consciousness on quantum processes throughout your nervous system. The experience of deliberation and choice might correspond to quantum computations that culminate in conscious decisions that influence physical reality. As you contemplate these possibilities, take a moment to notice your own experience of choice and decision-making right now. The fact that you can direct your attention, focus on different ideas, and choose how to respond to these concepts might reflect quantum processes occurring within your neural networks. Your consciousness might be literally influencing the physical structure of your brain through quantum mechanical processes at the molecular level. The implications extend beyond individual consciousness to collective human awareness and our relationship to the natural world. If consciousness influences quantum processes, then the combined awareness of all conscious beings might be shaping reality on a global or even cosmic scale. The thoughts, intentions, and awareness of billions of conscious entities might be continuously influencing the quantum processes that underlie all physical phenomena. This perspective offers a radically different understanding of environmental and social responsibility. Rather than being isolated, individuals whose thoughts and intentions remain private and inconsequential, we might be participants in a vast network of consciousness that collectively influences the physical world. Our mental states, emotional patterns, and conscious intentions might have subtle but real effects on the quantum processes that govern everything from local weather patterns to global ecological systems. However, we must be extremely careful not to overstate these possibilities or make claims that go beyond what current scientific evidence supports. The idea that individual thoughts or emotions directly influence large-scale physical events through quantum effects remains highly speculative and unsupported by rigorous scientific evidence. While it's fascinating to explore these connections between consciousness and the quantum realm, it's important to maintain scientific humility and avoid making claims that extend beyond what the evidence actually supports. The philosophical implications of quantum consciousness theories extend into questions about the nature of identity and selfhood. If consciousness emerges from quantum processes that operate according to non-local principles, then the boundaries of individual awareness might be more fluid than our everyday experience suggests. The sense of being a separate, isolated self might be a useful illusion created by the brain's classical processing systems, while the deeper quantum substrate of consciousness remains interconnected with the broader fabric of reality. This perspective finds resonance in the reports of experienced meditators who describe states of consciousness that transcend ordinary selfhood. During deep meditative absorption, practitioners often report a dissolution of the usual boundaries between self and world, a sense of unity that encompasses both observer and observed. While these experiences don't constitute scientific evidence for quantum consciousness, they do suggest that our ordinary sense of separate selfhood might not represent the full spectrum of conscious possibilities. As you rest into these ideas, notice how they might shift your relationship to your own sense of identity. The feeling of being a bounded self, separate from the world around you, might coexist with deeper levels of awareness that are more intimately connected to the quantum processes that underlie all physical phenomena. Your individual consciousness might be like a wave on the surface of a vast ocean of awareness that extends throughout the universe. However, we must be careful to distinguish between the subjective experiences reported in contemplative traditions and objective scientific claims about the nature of consciousness. The fact that meditation can produce profound alterations in subjective experience doesn't necessarily mean that these experiences correspond to quantum mechanical processes in any scientifically meaningful sense. Subjective profundity and objective scientific validity are different categories that shouldn't be confused. The implications of quantum consciousness theories also extend to our understanding of mental illness and psychological healing. If consciousness really does emerge from quantum processes in neural microtubules, then psychiatric disorders might involve disruptions in quantum coherence rather than purely classical neurotransmitter imbalances. This could open entirely new therapeutic approaches based on restoring quantum coherence rather than manipulating brain chemistry. Some researchers have speculated that practices like meditation, which appear to enhance neural coherence and integration, might work by optimizing quantum processes in the brain. The sense of clarity and well-being that often accompanies regular contemplative practice might reflect improved quantum coherence across neural networks. This remains highly speculative, but it illustrates how quantum consciousness theories could reshape our understanding of mental health and healing. The scientific investigation of these possibilities remains in its earlier stages, with most researchers maintaining appropriate skepticism about claims that extend beyond current evidence. The history of science is filled with elegant theories that seemed compelling but ultimately failed to match experimental reality. Quantum consciousness theories must prove themselves through rigorous testing rather than philosophical appeal alone. Yet the questions themselves remain profound regardless of how the scientific evidence ultimately develops. The mystery of consciousness, the puzzle of quantum measurement, and the relationship between mind and matter represent some of the deepest challenges facing human understanding. Whether or not consciousness plays a special role in quantum mechanics, these investigations are pushing us toward new insights about the nature of reality and our place within it. As we approach the culmination of our exploration into quantum consciousness, we find ourselves standing at the threshold of perhaps the most profound question facing modern science. What does it mean to exist in a universe where consciousness and quantum mechanics might be intimately connected? This isn't just an academic question confined to university laboratories and philosophical journals. It touches the very heart of what it means to be aware, to experience, to participate in the grand unfolding of reality itself. The journey we've taken together through the landscape of quantum consciousness has revealed a cosmos far stranger and more participatory than our everyday experience might suggest. We've seen how the act of observation appears to collapse quantum wave functions, transforming infinite possibilities into definite realities. We've explored theories proposing that consciousness emerges from quantum computations in the microscopic structures of our brains. We've grappled with the profound implications of a universe where mind and matter dance together at the deepest level of existence. Throughout this exploration, we've maintained a careful balance between wonder and skepticism, between openness to revolutionary possibilities and respect for scientific rigor. The theories we've discussed remain largely speculative, supported by intriguing evidence but far from scientific consensus. Yet the very fact that such questions can be investigated through controlled experiments represents a remarkable convergence of ancient philosophical inquiry with cutting-edge scientific methodology. As you integrate these ideas into your own understanding, take a moment to notice how they might influence your relationship to your own consciousness. The awareness you're experiencing right now, the stream of thoughts and sensations flowing through your mind, might be far more connected to the fundamental processes of the universe than you previously imagined. Each moment of conscious recognition might represent your participation in the ongoing creative process by which reality actualizes itself from quantum possibilities. This perspective doesn't diminish the mystery of consciousness, but deepens it. Rather than being an accidental byproduct of complex brain chemistry, awareness might be woven into the very fabric of existence. The questions you ask, the observations you make, the choices you face. All of these might represent genuine creative acts that contribute to the universe's ongoing process of self-discovery and self-actualization. The implications extend beyond individual consciousness to our collective human endeavor of understanding reality. Science itself becomes a profoundly participatory activity in which conscious observers don't just study the universe, but actively participate in its unfolding. Our theories, experiments, and discoveries might not be mere descriptions of pre-existing reality, but actual contributions to the process by which reality continues to create itself. This participatory vision of science aligns with the deepest insights of quantum mechanics, which reveal a universe that defies simple subject-object distinctions. The observer and the observed, the questioner and the mystery, the conscious mind and the quantum realm, all participate in a dance of mutual influence and creative emergence that transcends the boundaries of classical thought. Yet even as we embrace these possibilities, we must remain grounded in intellectual humility. The universe is under no obligation to conform to our desires for meaning, connection, or cosmic significance, reality might be far stranger than our quantum consciousness theories suggest, or it might be more mundane than our speculations hope. The beauty lies not in having definitive answers, but in the courage to ask profound questions and follow them wherever they might lead. The experimental investigation of quantum consciousness continues to evolve, with new technologies and methodologies opening previously impossible avenues of research. Future developments in quantum sensors, brain imaging techniques, and computational modelling might provide clearer evidence for or against the theories we've explored. The next decades will likely bring revelations that further transform our understanding of consciousness, quantum mechanics, and their potential intersection. What remains certain is that consciousness represents one of the deepest mysteries in all of science. Whether it emerges from classical neural networks, quantum computations, or something else entirely, the fact that the universe has evolved systems capable of subjective experience remains profoundly remarkable. Through consciousness, the cosmos becomes aware of itself, capable of wonder, inquiry, and the kind of exploration we've shared together. As you continue pondering these questions long after this exploration ends, remember that you're participating in one of humanity's greatest adventures, the attempt to understand the nature of mind and reality. Your curiosity, your wonder, your willingness to engage with these profound mysteries represents consciousness investigating itself, awareness studying awareness, the universe coming to know its own deepest nature through the eyes of conscious beings like yourself. The dance between consciousness and quantum mechanics continues, whether in laboratory experiments, philosophical discussions, or the quiet moments of reflection when you pause to contemplate the mystery of your own awareness. In that dance, in that ongoing exploration, in that willingness to remain open to possibilities beyond our current understanding, we find something beautiful and essentially human. The courage to wonder about our place in the vast, strange, and possibly conscious universe we call home. This exploration of quantum consciousness represents just one thread in the larger tapestry of questions about mind, matter, and meaning. Each insight opens new mysteries. Each answer reveals deeper questions. Each moment of understanding illuminates vast territories of the unknown. And perhaps that's exactly as it should be. Perhaps the greatest gift of consciousness isn't the answers it provides, but the questions it allows us to ask, the wonder it enables us to feel, and the ongoing adventure of discovery it makes possible. As we conclude this gentle journey through the quantum depths of consciousness, carry with you not dogma or certainty, but curiosity and wonder. Let these ideas percolate through your awareness like morning light filtering through leaves, illuminating new possibilities while leaving room for mystery. The universe continues to unfold its secrets through minds like yours, through moments of reflection like this, through the eternal dance between the known and unknown that makes existence such a beautiful and bewildering gift. The questions we've explored together, whether they lead to revolutionary scientific breakthroughs or remain as profound philosophical mysteries, remind us that we live in a cosmos far more wondrous than our everyday experience suggests. And in that wonder, in that openness to mystery, in that willingness to participate in the great conversation between mind and reality, we find something precious, our own consciousness awakening to its deepest nature and its cosmic significance. Whether consciousness collapses quantum wave functions or emerges from classical processes, whether the universe is fundamentally mental or purely physical, whether these questions have definitive answers or remain eternally mysterious, one thing remains beautifully certain. You are here, aware, capable of pondering these profound questions and participating in the universe's ongoing journey of self-discovery. And that perhaps is the most quantum phenomenon of all. If you've ever wondered whether consciousness might extend beyond the boundaries of individual brains, you'll find our exploration. If consciousness exists beyond the brain, everything you know is wrong. Both challenging and deeply illuminating. Until we meet again in the next exploration of mind and cosmos, rest well in the mystery and wonder of your own conscious awareness. Awareness. As we find ourselves at this crossroads between established science and speculative possibility, a remarkable transformation is occurring in laboratories around the world. Scientists are beginning to ask questions that would have seemed impossibly mystical just decades ago, yet they're approaching them with the rigorous methodology that has always defined good science. This convergence of ancient wisdom and cutting-edge research represents something unprecedented in human history. The systematic investigation of consciousness itself as a fundamental feature of reality. The technologies emerging from this research are beginning to blur the boundaries between science fiction and scientific fact. Imagine brain-computer interfaces that don't just read neural signals, but potentially tap into the quantum information processing that might be occurring within individual neurons. These systems could offer insights into consciousness that go far beyond what traditional neuroscience has been able to reveal. Early prototypes of such devices are already being tested in research settings, though their capabilities remain far from the speculative possibilities we've been exploring. Current brain-computer interfaces work by detecting the electrical activity of large groups of neurons, translating these signals into commands that can control external devices. But future generations might operate at much finer scales, potentially detecting the subtle electromagnetic signatures that could indicate quantum processes within neural microtubules. As you consider these technological possibilities, take a moment to reflect on how they might change our understanding of the boundary between mind and machine. If consciousness really does involve quantum processes, then the interfaces of the future might not just read our thoughts, but participate in the quantum computations that generate conscious experience. The line between biological and artificial intelligence could become surprisingly fluid. This technological trajectory raises profound ethical questions that we're only beginning to grapple with. If consciousness involves quantum processes that can be detected and potentially influenced by external devices, what are the implications for mental privacy? Could future technologies allow direct access to the quantum substrate of consciousness, bypassing the usual barriers between individual minds? These questions become even more complex when we consider the possibility of quantum networks connecting multiple conscious observers. If consciousness really does involve non-local quantum processes, then future technologies might enable forms of communication and information sharing that transcend the limitations of classical information transfer. This wouldn't necessarily involve telepathy in any supernatural sense, but rather technological amplification of quantum correlations that might already exist between conscious systems. Some researchers have begun exploring whether quantum entanglement between biological systems could provide the basis for such technologies. While the evidence remains extremely preliminary, studies have suggested that living cells might sometimes exhibit quantum correlations under certain conditions. If these correlations can be detected and enhanced through technological means, they could form the foundation for entirely new forms of communication and computation. The implications extend beyond individual consciousness to collective human awareness and decision-making. Imagine democratic processes that could somehow tap into the distributed quantum intelligence of entire populations, allowing for forms of collective decision-making that integrate information in ways that classical voting systems cannot achieve. While this remains highly speculative, it illustrates the kinds of possibilities that open up when we take seriously the idea that consciousness might involve quantum processes. However, we must be extremely cautious about rushing towards such applications without thoroughly understanding the underlying science. The history of technology is filled with innovations that seemed beneficial but created unintended consequences that weren't apparent until much later. Technologies that interface directly with consciousness could have implications that are difficult to predict or control. The research community has begun developing ethical frameworks for consciousness-related technologies, drawing on principles from bioethics, computer science, and philosophy of mind. These frameworks emphasize the need for informed consent, mental privacy, and protection of cognitive liberty. As the technology develops, these ethical considerations will become increasingly important for ensuring that consciousness research benefits humanity rather than creating new forms of exploitation or control. Take a breath now and notice how these technological possibilities might feel both exciting and slightly unsettling. The prospect of understanding consciousness more deeply is certainly appealing, but the idea of technologies that could interface directly with our innermost mental processes raises legitimate concerns about autonomy and privacy. This tension between potential benefits and risks is characteristic of many emerging technologies, particularly those that deal with fundamental aspects of human nature. The educational implications of quantum consciousness research are equally profound. If consciousness really does involve quantum processes, then our understanding of learning, memory, and cognitive development might need to be fundamentally revised. Traditional educational approaches assume that learning is essentially a classical process involving the strengthening of synaptic connections through repetition and reinforcement. But if quantum effects play a significant role, then optimal learning might involve entirely different principles. Some researchers have speculated that the sudden insights and creative breakthroughs that characterize deep learning might correspond to quantum computational processes that operate differently from classical information processing. The aha moments when understanding suddenly crystallizes might reflect quantum coherence events that integrate information across vast networks of neurons in ways that classical computation cannot achieve. This perspective could lead to new educational methodologies that attempt to optimize the conditions for quantum processes in learning environments. While this remains highly speculative, it suggests that factors like meditation, contemplative reflection, and states of relaxed awareness might play more important roles in education than traditional approaches recognize. The implications for artificial intelligence development are equally fascinating. If consciousness involves quantum processes that cannot be replicated by classical computers, then truly conscious artificial intelligence might require quantum computational substrates. This could explain why current AI systems, despite their impressive capabilities, seem to lack the subjective experience that characterizes biological consciousness. However, the development of quantum artificial intelligence faces enormous technical challenges. Current quantum computers are extremely fragile devices that require isolation from environmental noise to maintain their quantum properties. creating quantum AI systems that could operate in everyday environments would require breakthroughs in quantum error correction and noise management that may be decades away. Moreover, even if we could build robust quantum computers, we still don't understand enough about how quantum processes might generate consciousness to engineer artificial conscious systems. The gap between detecting quantum effects in biological systems and understanding how those effects give rise to subjective experience remains enormous. As you contemplate these future possibilities, consider how they might influence your own relationship to learning and personal development. If consciousness really does involve quantum processes, then practices that enhance quantum coherence in the brain might be more valuable than we currently recognize. This could include not just meditation and contemplative practices, but also activities that promote neural integration and coherence. The scientific investigation of these possibilities is proceeding along multiple fronts. Researchers are developing increasingly sophisticated tools for detecting quantum effects in biological systems, improving our understanding of how quantum processes might survive in noisy environments, and beginning to test whether quantum effects correlate with measures of consciousness and cognitive function. One particularly promising area of research involves the use of quantum sensors to detect the extremely subtle magnetic fields that might be generated by quantum processes in neural tissue. These devices are becoming sensitive enough to detect single quantum events, potentially allowing researchers to monitor quantum processes in living brains with unprecedented precision. Another important development is the growing collaboration between consciousness researchers and quantum physicists. Historically, these fields have operated in relative isolation, with consciousness researchers focusing on behavioral and neural measures, while quantum physicists worked primarily with inanimate systems. The growing recognition that consciousness and quantum mechanics might be connected has begun to break down these disciplinary boundaries. This interdisciplinary collaboration is leading to new experimental paradigms that combine techniques from both fields. Studies that simultaneously measure quantum properties and consciousness-related variables are beginning to provide data that could test the predictions of quantum consciousness theories. While the results remain preliminary, this research represents a genuine attempt to bridge the gap between subjective experience and objective measurement. The philosophical implications of these scientific developments continue to evolve as our understanding deepens. The possibility that consciousness involves quantum processes challenges traditional assumptions about the nature of mind, matter, and causation. It suggests that the universe might be far more integrated and participatory than classical science assumed, with conscious observers playing active roles in the unfolding of physical reality. Yet this participatory vision doesn't necessarily imply that consciousness has unlimited power to influence physical events through quantum effects. The constraints imposed by physical laws remain operative even if consciousness plays a role in quantum processes. The universe might be participatory, but it's not arbitrary. Reality emerges from the interaction between conscious observation and physical constraints in ways that we're only beginning to understand. As we look toward the future of consciousness research, the questions become increasingly profound. Will we discover that consciousness is indeed fundamental to the universe, present at all scales, from quantum particles to cosmic structures? Will we find that biological consciousness represents just one manifestation of a more universal property of information processing systems? Or will we conclude that consciousness is a purely biological phenomenon that has no special relationship to quantum mechanics? The answers to these questions will likely emerge gradually over the coming decades as our experimental capabilities continue to improve and our theoretical understanding deepens. What seems certain is that the investigation of consciousness will continue to push the boundaries of science, philosophy, and technology in ways that could transform our understanding of what it means to be conscious beings in a quantum universe. In quiet retreat centers around the world, something remarkable is happening that might revolutionize our understanding of consciousness and its relationship to quantum reality. Experienced meditators, some with decades of contemplative training, are becoming willing participants in scientific studies that probe the deepest nature of awareness itself. These practitioners represent a unique resource for consciousness research. Human beings who have learned to observe their own minds with extraordinary precision and stability. The convergence of contemplative practice and consciousness science represents a fascinating development in our ongoing exploration of quantum consciousness theories. While traditional neuroscience typically studies consciousness from the outside, measuring brain activity and behavioral responses, contemplative practitioners offer something different: highly trained first-person perspectives on the nature of awareness itself. Consider what happens when someone dedicates years to the systematic observation of their own consciousness through meditation practice. They develop the ability to notice subtle changes in attention, to detect the arising and passing of thoughts with microscopic precision, to observe the boundaries between different states of awareness. In essence, they become human instruments capable of detecting features of consciousness that might be invisible to external measurement. This contemplative expertise becomes particularly relevant when we consider the possibility that consciousness might involve quantum processes. If quantum effects in the brain are subtle and easily disrupted by external measurement, then the trained introspection of experienced practitioners might provide access to phenomena that laboratory instruments cannot detect. The meditator's awareness becomes, in effect, a quantum sensor operating from within the very system being studied. As you reflect on this possibility, notice your own capacity for self-observation right now. Even without years of meditation training, you can detect the flow of thoughts through your mind, the shifting of attention from one object to another, the subtle changes in the quality of awareness itself. This natural capacity for introspection, refined through contemplative training, might provide unique insights into the quantum nature of consciousness. Recent studies have begun to explore what happens in the brains of experienced meditators during different states of contemplative absorption. Advanced practitioners report experiences that seem to transcend the ordinary boundaries of individual consciousness, states of awareness that feel boundless, interconnected, and somehow more fundamental than everyday waking experience. Neuroscientists studying these states have discovered unusual patterns of brain activity that differ significantly from ordinary waking consciousness. During deep meditative absorption, the usual networks of brain activity that maintain our sense of separate selfhood become less active, while other networks associated with awareness itself become more prominent. It's as if the meditator's consciousness is shifting from a localized individual mode to something more distributed and unified. Some researchers have speculated that these altered states might involve increased quantum coherence across neural networks. The sense of unity and interconnectedness reported by meditators might correspond to quantum entanglement between different regions of the brain, creating a more integrated form of information processing than typically occurs during ordinary consciousness. This remains highly speculative, but it illustrates how contemplative experience might provide insights into quantum processes that are difficult to study through purely external methods. The meditator's subjective reports of unity, interconnectedness, and expanded awareness might be describing genuine quantum phenomena from a first-person perspective. However, we must be extremely careful not to conflate subjective experience with objective quantum processes without rigorous scientific verification. The fact that meditation produces profound alterations in consciousness doesn't automatically mean that these changes involve quantum mechanics in any scientifically meaningful sense. Correlation between contemplative reports and quantum theories doesn't establish causation or even meaningful connection. The scientific study of contemplative states faces unique methodological challenges. How do you objectively measure subjective experience? How do you verify first-person reports about the nature of consciousness? How do you design experiments that can test whether contemplative insights correspond to genuine features of quantum reality? Some researchers have developed innovative approaches to these challenges. They train meditators to provide detailed, systematic reports about their inner experience while simultaneously monitoring their brain activity through EEG, fMRI, and other neuroimaging techniques. This allows for correlation between subjective reports and objective measurements, potentially revealing connections that wouldn't be apparent from either perspective alone. Other studies focus on the behavioral and cognitive changes that result from contemplative training. If meditation really does optimize quantum processes in the brain, then experienced practitioners should show enhanced performance on tasks that might depend on quantum computation, creative problem solving, pattern recognition, integration of complex information, and other cognitive abilities that seem to transcend classical computational limits. The results of such studies remain mixed and inconclusive. Some research suggests that experienced meditators do show enhanced cognitive abilities and unusual patterns of brain activity, but it's unclear whether these changes involve quantum processes or can be explained through purely classical mechanisms. The field requires much more research before drawing definitive conclusions about the relationship between contemplative practice and quantum consciousness. Take a moment to consider how contemplative practice might relate to your own experience of consciousness. Whether or not meditation involves quantum processes, it clearly has the capacity to reveal aspects of awareness that remain hidden during ordinary states of consciousness. The sense of peace, clarity, and expanded awareness that often accompanies contemplative practice might provide genuine insights into the nature of mind, regardless of its relationship to quantum mechanics. The integration of contemplative wisdom and quantum consciousness research also raises important questions about the cultural and historical context of consciousness studies. Contemplative traditions have been exploring the nature of consciousness for thousands of years, developing sophisticated maps of different states of awareness and techniques for accessing them systematically. These traditional approaches to consciousness often include ideas that seem to resonate with quantum mechanical concepts, the interconnectedness of all phenomena, the role of observation in shaping reality, the fundamental nature of awareness itself. While we must be cautious about reading modern physics into ancient wisdom traditions, there might be genuine insights about consciousness that these traditions have preserved through millennia of systematic investigation. The dialogue between contemplative traditions and quantum consciousness research is creating new possibilities for understanding awareness that draw on both ancient wisdom and modern science. This integration doesn't require accepting traditional metaphysical claims uncritically, but it does involve taking seriously the phenomenological insights that contemplatives have developed through direct investigation of consciousness. Some researchers have proposed that the optimal approach to consciousness studies might involve what they call contemplative science, a methodology that combines the rigor of scientific investigation with the precision of trained first-person observation. This approach acknowledges that consciousness has both subjective and objective dimensions that need to be studied using appropriately matched methodologies. If you're drawn to exploring these possibilities in your own experience, consider how contemplative practice might enhance your understanding of consciousness, regardless of its relationship to quantum mechanics. The systematic observation of your own mind through meditation or other contemplative techniques can reveal aspects of awareness that remain invisible during ordinary activities. This doesn't require accepting any particular theoretical framework about quantum consciousness, but simply involves developing greater familiarity with the landscape of your own awareness. Through such practice, you might discover that consciousness is far more spacious, flexible, and mysterious than everyday experience suggests. The contemplative investigation of consciousness also opens possibilities for understanding the relationship between individual awareness and larger patterns of consciousness that might exist at collective or even cosmic scales. Advanced practitioners sometimes report experiences that seem to transcend the boundaries of individual selfhood, accessing states of awareness that feel universal or transpersonal. While these experiences don't constitute scientific evidence for quantum consciousness theories, they do suggest that our ordinary sense of being isolated individual minds might not represent the full spectrum of conscious possibilities. The boundaries between self and world, observer and observed, individual and universal awareness might be more fluid than we typically assume. As the dialogue between contemplative traditions and quantum consciousness research continues to evolve, it promises to enrich both domains. Contemplatives gain access to scientific methodologies that can test and refine their insights about consciousness, while scientists gain access to systematic first-person investigation techniques that have been refined over centuries of practice. This integration represents something unique in the history of consciousness studies: the possibility of understanding awareness from both interior and exterior perspectives simultaneously. Rather than privileging either subjective experience or objective measurement, this approach attempts to honour both dimensions of consciousness as legitimate and necessary aspects of a complete understanding. Whether or not this integration ultimately provides evidence for quantum theories of consciousness, it's already demonstrating the value of bringing together different ways of knowing about the mind. The result is a richer, more nuanced understanding of consciousness that draws on humanity's full range of investigative capabilities. As we expand our exploration beyond individual consciousness, a fascinating question emerges. If consciousness really does interface with quantum processes, what might this mean for the complex systems that emerge from the interactions of many conscious beings? Could there be quantum effects that operate at the level of societies, ecosystems, or even larger scales of organisation? This speculative territory takes us to the very edges of current scientific understanding, where individual awareness might participate in larger patterns of information processing and coordination. The study of complex systems has revealed that simple interactions between individual components can give rise to emergent properties that transcend what any single component could achieve alone. Consider how individual neurons, each following relatively simple rules, somehow give rise to the rich complexity of conscious experience, or how individual cells, operating according to their local chemical environments, coordinate to create the integrated functioning of entire organisms. These emergent phenomena suggest that consciousness might not be confined to individual brains, but could arise at multiple scales of organisation. If quantum processes play a role in individual consciousness, they might also contribute to higher order forms of awareness that emerge from the interactions of multiple conscious systems. This possibility opens up entirely new ways of thinking about collective intelligence, social coordination, and even ecological awareness. Some researchers have speculated about what they call quantum social effects, hypothetical phenomena where quantum correlations between individual consciousness systems could facilitate forms of coordination and communication that transcend classical information transfer. While this remains highly speculative and unsupported by current scientific evidence, it illustrates the kinds of possibilities that emerge when we consider consciousness as potentially involving quantum processes. As you contemplate these ideas, take a moment to notice your own participation in various collective systems, the social groups you belong to, the communities you're part of, the cultural patterns you participate in. All of these might involve forms of information sharing and coordination that operate below the threshold of conscious awareness. Could some of these collective phenomena involve quantum processes that connect individual consciousness systems in subtle ways? The investigation of such possibilities faces enormous methodological challenges. How would you design experiments to test for quantum effects operating at social or ecological scales? How would you distinguish between quantum coordination and the many classical mechanisms that already explain most collective behaviours? How would you control for the countless variables that influence complex systems? Despite these challenges, some researchers have begun exploring whether groups of people might sometimes exhibit coordinated behaviours that cannot be fully explained through classical communication and social influence. Studies of group meditation, collective decision-making, and even audience responses to performances have occasionally revealed patterns of synchronization that seem to emerge more rapidly than classical information transfer would predict. However, it's crucial to emphasize that these findings remain highly controversial and have not been consistently replicated. The scientific community maintains significant skepticism about claims of quantum effects in social systems, and rightfully so. The human tendency to find patterns and meaning in complex data is particularly strong when studying phenomena as personally meaningful as consciousness and social connection. The complexity of social systems provides numerous opportunities for apparent coordination to emerge through purely classical mechanisms. Shared cultural backgrounds, subtle environmental cues, unconscious behavioural mimicry, and many other factors can create the appearance of mysterious coordination without requiring any quantum processes. Extraordinary claims require extraordinary evidence, and the evidence for quantum social effects remains far from extraordinary. Yet the questions themselves remain intriguing from both scientific and philosophical perspectives. If consciousness does involve quantum processes, then the interactions between conscious beings might involve quantum correlations that we don't yet understand how to detect or measure. The apparent boundaries between individual minds might be more permeable than our everyday experience suggests. This possibility finds some support in research on empathy, emotional contagion, and other forms of interpersonal synchronization. Studies have shown that people in close proximity often unconsciously synchronize their breathing, heart rates, and even brain activity. While these phenomena can largely be explained through classical mechanisms, they do suggest that individual consciousness systems are more interconnected than we might assume. The investigation of collective consciousness phenomena also intersects with research on emergent properties in complex networks. Studies of neural networks, social networks, and ecological networks have revealed principles of organization that might apply to consciousness as well. Information processing systems that are highly interconnected and dynamically active often exhibit emergent properties that transcend what their individual components could achieve alone. If consciousness involves quantum processes, then networks of conscious beings might exhibit emergent quantum properties that operate at scales larger than individual brains. This could provide a physical basis for phenomena like collective intelligence, group intuition, or shared emotional states that seem to emerge from group interactions. However, we must be extremely cautious about making claims that extend beyond what current scientific evidence supports. The existence of emergent properties in complex systems doesn't automatically imply that these properties involve consciousness or quantum processes. Many complex systems exhibit remarkable coordination and intelligence-like behaviors without any need for conscious awareness or quantum mechanics. Take a breath here and consider how these speculative possibilities might influence your understanding of your own social relationships. Whether or not quantum processes play a role, the connections between conscious beings clearly involve forms of information sharing and mutual influence that operate below the threshold of explicit communication. Your presence affects others in ways you might not fully recognize, just as their presence affects you. The ecological implications of these ideas are equally fascinating to contemplate. If consciousness involves quantum processes that operate at multiple scales, then the interactions between conscious beings and their environments might involve quantum correlations that connect individual awareness to larger ecological patterns. This could provide a physical basis for the sense of connection to nature that many people report, particularly in wilderness settings or during moments of deep ecological awareness. Some researchers have speculated about ecological consciousness, a hypothetical form of awareness that emerges from the complex interactions between living systems and their environments. While this remains highly speculative, it illustrates how quantum consciousness theories might extend beyond individual brains to encompass larger scales of organization and awareness. The study of plant intelligence and communication has revealed that botanical systems exhibit forms of information processing and coordination that were previously unrecognized. Plants can communicate through chemical signals, coordinate their responses to environmental challenges, and even exhibit what appears to be learning and memory. While these phenomena don't necessarily involve consciousness as we understand it, they do suggest that intelligence and information processing extend far beyond animal nervous systems. If quantum processes play a role in biological information processing, then the sophisticated coordination observed in plant communities, forest ecosystems, and other natural systems might involve quantum effects that we're only beginning to understand. The mycorrhizal networks that connect forest trees through underground fungal webs, for instance, facilitate information sharing and resource distribution across vast areas. Could these networks involve quantum processes that enhance their coordination and efficiency? These questions push us toward a vision of consciousness and intelligence that extends throughout the natural world, operating at scales from quantum particles to planetary ecosystems. While this vision remains highly speculative and unsupported by current scientific evidence, it illustrates the kinds of possibilities that open up when we consider consciousness as potentially fundamental to the organization of complex systems. As you reflect on your own place within these larger patterns of organization, consider how your individual consciousness participates in multiple levels of complex systems simultaneously. You're part of social groups, ecological communities, and ultimately the planetary system that supports all life on Earth. Your thoughts, choices, and awareness contribute to these larger patterns in ways that might be more significant than you typically recognize. Whether or not these contributions involve quantum processes, the fact remains that consciousness represents one of the most remarkable phenomena in the known universe. Through awareness, the cosmos becomes capable of studying itself, understanding its own nature, and perhaps even influencing its own evolution. In that sense, consciousness might indeed be fundamental to the universe's ongoing process of self-organization and self-discovery, regardless of its specific physical mechanisms. As our exploration of quantum consciousness theories continues to evolve, we encounter questions that extend far beyond the laboratory and into the realm of human values, responsibility, and ethical consideration. If consciousness really does play a fundamental role in quantum processes, what are the moral implications of this possibility? How should it influence the way we treat other conscious beings, make decisions about technology development, and understand our responsibilities as aware participants in reality? The ethical dimensions of quantum consciousness research are particularly complex because they involve both established scientific principles and highly speculative theoretical possibilities. We must navigate between taking these ideas seriously enough to consider their implications while maintaining appropriate skepticism about claims that extend beyond current evidence. This balance requires a form of ethical reasoning that can accommodate uncertainty while still providing guidance for action. Consider first the implications for how we understand moral responsibility. Traditional ethics often assumes that individuals are relatively isolated agents whose choices primarily affect themselves and those in their immediate vicinity. But if consciousness involves quantum processes that operate according to non-local principles, then the boundaries of moral responsibility might extend far beyond what we typically assume. The quantum mechanical phenomenon of entanglement demonstrates that particles can maintain instantaneous correlations regardless of the distance separating them. If consciousness involves similar non-local correlations, then our thoughts, intentions, and choices might have subtle influences that extend far beyond our immediate environment. This doesn't mean that individual thoughts directly control distant events, but it does suggest that the effects of consciousness might be more far-reaching than classical physics would predict. As you contemplate this possibility, take a moment to consider how it might influence your own sense of ethical responsibility. If your consciousness really is connected to larger patterns of quantum information processing, then your mental states, emotional patterns, and conscious choices might contribute to collective phenomena in ways that you don't directly perceive. This could suggest a form of moral responsibility that extends beyond immediate actions to include the quality of consciousness itself. However, we must be extremely careful not to overstate these possibilities or use them to support claims about direct mental influence on physical events. The scientific evidence for such effects remains extremely limited and controversial. While it's worth considering the ethical implications of quantum consciousness theories, we shouldn't base moral decisions on unproven speculative possibilities. The development of technologies that might interface with consciousness raises additional ethical concerns that are more immediate and practical. Brain-computer interfaces, quantum sensors capable of detecting neural activity, and other consciousness-related technologies could have profound implications for mental privacy, cognitive liberty, and human autonomy. If consciousness involves quantum processes that can be detected and potentially influenced by external devices, then future technologies might provide unprecedented access to the most intimate aspects of human experience. The ability to monitor or influence quantum processes in the brain could represent either a remarkable therapeutic opportunity or a dangerous threat to mental freedom, depending on how such technologies are developed and regulated. The ethical frameworks we use to evaluate these technologies will need to address questions that haven't previously been relevant to human experience. What constitutes consent when dealing with technologies that might access unconscious quantum processes? How do we protect mental privacy when the boundaries of individual consciousness might be more fluid than we assume? How do we ensure that consciousness-enhancing technologies benefit humanity rather than creating new forms of inequality or exploitation? As our exploration of quantum consciousness theories continues to evolve, we encounter questions that extend far beyond the laboratory and into the realm of human values, responsibility, and ethical consideration. If consciousness really does play a fundamental role in quantum processes, what are the moral implications of this possibility? How should it influence the way we treat other conscious beings, make decisions about technology development, and understand our responsibilities as aware participants in reality? The ethical dimensions of quantum consciousness research are particularly complex because they involve both established scientific principles and highly speculative, theoretical possibilities. We must navigate between taking these ideas seriously enough to consider their implications while maintaining appropriate skepticism about claims that extend beyond current evidence. This balance requires a form of ethical reasoning that can accommodate uncertainty, while still providing guidance for action. Consider first the implications for how we understand moral responsibility. Traditional ethics often assumes that individuals are relatively isolated agents whose choices primarily affect themselves and those in their immediate vicinity. But if consciousness involves quantum processes that operate according to non-local principles, then the boundaries of moral responsibility might extend far beyond what we typically assume. This remains a speculative idea, not a proven scientific fact, yet it opens fascinating questions about the nature of our interconnectedness. The wave function might not exist as we imagine it, or it might be more real than the chairs we sit on. Consciousness might collapse quantum possibilities into definite realities, or it might simply be along for the ride as classical physics unfolds in our brains. The questions we've explored together remain beautifully, stubbornly open, inviting us to sit comfortably with mystery rather than rushing toward premature conclusions. What we can say with quiet confidence is this: the investigation of consciousness and quantum mechanics has revealed something profound about the nature of scientific inquiry itself. These are questions that push us to the very edges of what can be known, where mathematics meets subjective experience, where ancient philosophical puzzles encounter cutting-edge experimental techniques. Whether consciousness plays a special role in quantum processes or emerges from purely classical mechanisms, The fact that we can even contemplate these possibilities represents something remarkable about the universe we inhabit. Perhaps the most beautiful discovery isn't whether consciousness collapses wave functions, but that consciousness exists at all. Through awareness, the cosmos has developed the capacity to study itself, to wonder about its own deepest nature, to ask questions that stretch across the boundary between mind and matter. In every moment of conscious recognition, in every act of attention and understanding, the universe is quite literally coming to know itself through eyes like yours. As you drift away from these explorations and back into your daily experience, carry with you not answers, but deeper questions. Notice the mystery of your own awareness as it flows from thought to thought, from sensation to recognition to choice. Whether that awareness involves quantum processes or classical neural networks, it remains one of the most extraordinary phenomena in existence. The wave function may or may not be real, but your conscious experience of pondering that question certainly is. And in that pondering, in that willingness to sit with uncertainty while remaining open to wonder, consciousness reveals its most quantum property of all, the ability to exist simultaneously in multiple states of knowing and not knowing, of certainty and mystery, of scientific rigor and philosophical awe. Until we meet again in the exploration of mind and cosmos, rest gently in the beautiful uncertainty of your own conscious awareness.